So I uploaded 3 different pictures. One for a cat, one for a parrot, and one picture of Cristiano Ronaldo. So let's search, for example, cat. You can see that it is easily finding the related image to your query. I'm gonna go ahead and type parrot, and you can see that again, it is finding the related document. Let's also try football. You can see that it is showing the picture regarding Cristiano Ronaldo. So if I'm gonna go and search for canary, it will understand that parrot is a bird and canary is a bird, so they are very related. So the most related picture that we have in our database is the one for the parrot, so we are showing this again for the query of canary. Let's also see how reverse search would work. I'm gonna go here. I'm gonna upload another cat picture, and I expect that it will show me the other cat. Yeah, amazing. So what I uploaded was this picture, and it successfully found out that this is a cat and showed me the cat that we have in our database. Hey everyone, Nariman here, welcome to my channel. Today we want to build a very simple local image search. I'm gonna build this image search engine in 2 ways. First one would be using text, like you go to Google and search for images of cats, dogs, or any other queries. And the other one, which is famous as reverse search, which Google also has it. Let's say you upload an image into the search engine, and then you will get all the related images to that. Like if you uploaded a cat image, you expect to see more cat images in response. To be able to search images, we need to bring these images into vector space. We can do this in 2 ways. The first approach would be to ask a computer vision model to describe this image. And then you can bring this description, this text, into vector space. The second approach is to bring image directly into vector space using embeddings. To keep things simple, I'm going to use the first approach. For this, I need a very good vision model. So I will use Ollama's open source models. I will also use LangChain, which offers me lots of tools to work with LLMs. If you are not familiar with Ollama and LangChain, I will suggest you also watch my previous video. I'm also going to use the Streamlit to build a good UI for my web application. If you want to also get familiar with the Streamlit, I would suggest you watch this video. So first, let's run our vision model locally. I'm gonna use Ollama's website and search into models. I decided to use LLaVa, which is a vision model that is very powerful. You can see that here it's tagged as vision, and it has 3 different variations. I'm gonna use the 34B one. If you go down there, you can see that easily by typing Ollama run LLaVa in your command line, you can run this model. So let's go ahead and do that. I'm gonna go to the terminal and copy this command. And as I told you, I'm gonna choose the 34B one. As you can see, since I already pulled it before, I can interact with it right away. But if you didn't do it before, first it's gonna take a while to download it. Now let's go through our project. I'm gonna go to my IDE, and here is our dependencies. As I told you, I'm gonna use a Streamlit for building a good UI, and then a bunch of LangChain tools, and of course the LangChain Ollama integration, because I'm gonna use one of Ollama's model. I already installed these, but we will go ahead and see if we need more dependencies or not. So at first I want to create an image store. I already created a Python file. I decided to use static methods and also static class variables, because I want to share this information across multiple Streamlit pages. This is basically the skeleton. I need some embedding model. I'm using Llama 3.2 for embeddings and some vector store. I'm just using in-memory vector store for this showcase. Doesn't matter for now. So we need embedding model to bring the description of the image into vector space. And then we need this vector store to store these vectors. This image store basically do three important things. First of all, it will upload the image inside a directory called images. I already created a directory here. So what we will do is the user will upload the file. We will save it in this directory. Next, we will ask the LLaVa vision model to describe this image. Then we will bring this description into vector space and then store it in vector store. The last thing is to serve information. We need to search through these images and retrieve them. So let's start coding and I will explain to you more in depth what we are going to do. We are going to start with upload file. So here we are going to have a file. All I need to do is first store it in the images directory. So with open, and here is the cls.images directory, and then the file name, and eventually we will write it to this directory. This is basic Python, writing a file to a directory. Now I need to describe this image using the vision model. I already created this method, this private method called describe image. I'm gonna call this one here with the image pass, and then I'm gonna store it in a variable called description. Now I want to store this description inside a vector store. So first I will wrap it inside LangChain's document. Let's create a document and put the description as the page content. And then it's very easy. I just gonna call the vector stores add documents method and pass this document. By doing this, the vector store would call the embeddings on it and make a vector out of this document and then store it. So here we need to call CLS, and in return we will get document IDs. So it will assign an ID to this document after storing it, like all the relational databases that we worked with. And I need to keep this somewhere because I'm gonna later retrieve this image by ID, and I need to create a mapping between this document ID and the actual image. So I'm gonna create a Python dictionary called document IDs to images and store this information inside that. So let's go ahead and do this. I will say document IDs to images, and then I would say document ID 0, because it's gonna return me a list of IDs, but I'm pretty sure that I just stored one document, so there will be only one ID there. And I will say store the name here. So this thing also needs a CLS. It will be also necessary to have a mapping between ID and the document itself. So I'm going to create another map called document IDs to documents. And then what I'm going to do is also store the document itself in here. So now I'm able, whenever I want, to retrieve the document or the image by ID. At the end, I'm just gonna return the document ID, something like that. And we are done with the upload image. Now we need to ask the LLaVa model to describe this image that was uploaded to us. I'm gonna create an Ollama chat, and then as model, I'm gonna choose LLaVa as I told you. And then I need to write a message, a prompt. I'm gonna say messages, and then I will need to pass a role, which is a user. User is asking some questions. Then would be the content, which is actually our prompt. And then there would be also a third part, which is called images, where we are gonna pass the image path here. Before writing our prompt, let's store this inside a variable, and at the end we need to return the response message, if I'm not mistaken, and then content. This will be the description that we get from the LLaVa model. So for prompt, first let me organize it a little bit here. So for prompt, I'm gonna say, tell me what do you see in this picture. That's it. Maybe also say in only one sentence. And also let's stress that be concise. So I don't want to get like one paragraph, two paragraph in every detail about the image. I just want to know what is exactly in this picture. Is it a dog? Is it a bird? Is it a person? You know? So I think that's good enough for now. One more thing that I want to add here is to set the temperature to 0. Temperature controls the randomness. So since we are probably going to run it a few times and try things out, I don't want to get surprised every time. I want very consistent results from the model. So let's go ahead and do this. In options, you can set the temperature to 0. Yeah, perfect. So this will be the description of our image. This is how we are generating an image description. So we get a text, so we can bring this text to vector space. Now that the image is uploaded and the description is in the vector store, we need to serve the related documents. User would write cats, dogs, anything. So we have a query, we will pass this query to the vector store and we will get all the related documents. That's simple. Here, I would call vector cls.vector store. And yeah, I'm gonna use similarity search and pass the query. This K would show you how many documents what you want to retrieve. You will set a limit. You will say, every time I pass a query to the vector store, I want to get maximum 5 documents or 10 documents. I'm gonna put this on 1 for now, because we are just gonna upload a few pictures. It's not that much. And that is basically our retrieval. Just that. I'm gonna return this, and it will return all the related documents to this query. For the reverse search, things are a little bit more complicated. User is passing you an image, and you need to find all the related images to that. You don't have any text or any query to go through vector store and retrieve everything. So I again need my vision model to describe this image to see what's in there. And I will use that description as query to retrieve all the related images. For this, again, I will save this image in the images directory. We had this. And then we will ask the describe image method and our model to describe it. And now we have a text as query. So we are gonna call the retrieve docs by query with the description. So I'm gonna go ahead and say return retrieve docs by query, and I will pass this description as query. And for this error here, we need to call CLS, and this was also the error regarding not calling it on the class name. So now everything should be fine. And at last, these two methods are also very simple. We want to retrieve by ID the document sometimes, and we want to retrieve the image itself sometimes by ID. So we need these two. It's very simple. It's just calling the map. So this one is document IDs to documents. And to retrieve the images, we need the other dictionary, document IDs to images. Now that we are done with the images store, let's go ahead and create a nice UI for our application. As I told you, I'm going to use a Streamlit. We need one page for uploading images. So I'm going to call it upload images. Let's import a Streamlit. First, I'm gonna give it a title called upload images. And then we need a file uploader. It's gonna say, yeah, choose an image. I'm gonna accept maybe multiple files, yeah. And I'm gonna only accept like conventional image formats, like PNG. I'm gonna store it in a variable. The result will be the uploaded files or uploaded images, doesn't matter. Let's also format this a little bit so you can see better. And now I'm gonna go through files one by one. For uploaded file, in uploaded files, I'm gonna call the images store with the upload image method. I'm gonna pass these files one by one. And if you remember, upload image is going to return the ID. So I'm gonna store it in a doc ID. And at the end, I'm gonna show the user the uploaded image with the description that we generated. So I'm gonna say st.image. This will show an image to the user. The first one would be the pass of the image. If you remember, we had a method for this. Get image pass by ID. I'm gonna pass the ID. And as caption, we are gonna show the user the description that we generated. I'm gonna use the other method to get the document. It was get by ID, doc ID, and the documents of LangChain has a field called page content that we are gonna use. So I think this is good enough for the file uploader. We need a page to search by keywords. I'm gonna call it image search. Let's again import Streamlit. I'm gonna give it a title called maybe image search, I don't know. Let's say image search. It's very simple. It is going to be a text input. And I'm gonna say, yeah, maybe enter query. I'm gonna save this inside the query. And we are gonna call our images store with the retrieve docs by query, pass the query. The result would be retrieved docs. We are gonna go through these docs. I know that for now we decided to go with one only, but let's do it as a for loop. Yeah, I'm gonna go through the documents, and then again, as I showed you before, I'm gonna display this image, bypass, and I'm gonna show the caption also here. This is the description that the LLaVa model gave us. Yeah, I think this is good enough. Let's go also create a page for reverse image search when the user would upload a file. So since it's very close to upload images, I'm gonna copy this file, but call it reverse image search or something. Yeah, let's call it reverse search. It has some differences. Here we should say reverse search in the title, maybe reverse image search, I don't know. Again, we are asking for some files. Here I'm gonna say you cannot upload multiple files, just one file, but the others can stay. What I'm gonna do is pass this uploaded file to the image store and retrieve by image. Upload file, there will be retrieve docs, not this retrieve docs. And to show images, I can just copy the one that I have for image search. I'm just gonna go over all the return documents and show them. Actually, one more thing, since we are not accepting multiple files, so this one is not a list. So what we can do is if uploaded file, then do this. Yeah, this should work. So you notice that we have 3 different Streamlit pages and we need somehow to navigate between them. The user should be able to go and upload file and then go to the search page. So I'm gonna create another Python file, maybe called app.py, to create this navigation. I'm gonna import a Streamlit again. Then I'm gonna create a navigation. This navigation will expect a list of pages from me. I have 3 pages. I should create a list. Yeah, the first page can be upload images. You will say the title. You will also say the name of the Python file, and you can also define an icon for it. The next one, let's see what GitHub Copilot would suggest to us. Yeah, the next one would be image search, which has the text box, and yeah, this icon is also good for it. And the third one would be the reverse search, which user uploads a file, and the Python page responsible for that is reverse search.py. Let's keep also the icons, they look nice. This navigation will send the first page as the default, and I'm gonna run this page. So that's it, we are done with everything. We can now run our Streamlit application and see if it has any problems. We will fix it, and we will see how our application would look like. So let's go to the command line, and all I need to do is call Streamlit run app.py. As I told you, app.py is our entry point. So let's run this. So let's go to the browser, and here we go. We have a couple of pages. This is where you can upload images. I'm gonna upload one image, and of course we are gonna have some errors. Let's see. It's saying something is wrong with the Ollama chat. Let's go over to the code and see. Let me see. So I'm gonna go to the method itself, the model, the messages. Yeah, I think there is something wrong with the messages. Let me go back. Yeah, I passed something like a dictionary, which actually it should be like a sequence. So let's fix that. And then inside this sequence, let's pass a dictionary, something like that. I think that is the problem. So let's just start over and try again. I'm gonna go to the terminal. I'm gonna stop this, run it again. Let's go to the browser. I'm gonna upload a couple of files. It's gonna take a while because like describing an image takes some time. So yeah, we uploaded a parrot and the description is a colorful parrot with its head turned to the side, perched on a branch. So you can see that the vision model is really good. I'm gonna also upload a couple of more. Let's do another one. So let's see, we have a parrot, we have a cat with this description, and we have an image of Cristiano Ronaldo. It's also saying like it's a soccer player with this and that. So we have 3 pictures. Let's go to the search. This parrot is being shown here because we sent an empty query and then it's just returning something. You can also handle it in the code if the query is empty, do nothing, etc. Doesn't matter here. So I uploaded 3 different pictures. One for a cat, one for a parrot, and one picture of Cristiano Ronaldo. So let's search, for example, cat. You can see that it is easily finding the related image to your query. I'm gonna go ahead and type parrot, and you can see that again, it is finding the related document. Let's also try football. You can see that it is showing the picture regarding Cristiano Ronaldo. And this is the cool thing about semantic search. It doesn't necessarily match word by word. It understands that football is related to Cristiano Ronaldo. So it will always show you the images that are closer to your topic. So if I'm gonna go and search for canary, it will understand that parrot is a bird and canary is a bird, so they are very related. So the most related picture that we have in our database is the one for the parrot, so we are showing this again for the query of canary. Let's also see how reverse search would work. I'm gonna go here. I'm gonna upload another cat picture and I expect that it will show me the other cat. Yeah, amazing. So what I uploaded was this picture and it successfully found out that this is a cat and showed me the cat that we have in our database. One thing to note is that this was just a simple showcase, some kind of MVP. Please be mindful that searching and ranking is much more complicated in the real world applications. I hope you enjoyed watching this video. Please also push the like button and also subscribe me for more content like this. See you around.